Hey there! Recently I posted an MCQ on my social media platforms, and while posting the MCQ itself, I thought this is an easy one. I mean, majority will give a correct answer. But when I saw the percentages of the various options ticked, I realized that it needs further explanation because majority of the students in fact gave wrong answer. So here is the MCQ. Which of the following is a result of digitalis toxicity? And it's related to the changes in the plasma ion concentrations. The options were hypernatremia, increased plasma sodium; hyponatremia, decreased plasma sodium; hyperkalemia, increased plasma potassium; or hypokalemia, decreased plasma potassium concentration. To my surprise, many students were thinking about sodium concentrations. They marked hyper or hyponatremia. Well, the answer, you want to try this? What's your answer? Well, the answer is hyperkalemia. Now let's check it out why the answer is hyperkalemia by talking about the mechanism of action of digitalis. Now, digitalis is a cardiac glycoside. It is known to increase the myocardial contractility, strength of contraction of the heart. It's called as positive inotropic effect, and therefore it is given in the conditions of heart failure. You know, heart failure means heart fails to pump. It fails as a pump, reduced stroke volume, and by giving digitalis, we increase the strength of contraction of the heart and stroke volume is restored. How does it achieve this? It acts on the sodium potassium pump, our champ, the sodium potassium pump. You know, sodium potassium pump is present everywhere in the body, in all membranes. So is the case with cardiac myocytes, cardiac muscle cells. In the membrane of heart muscle cells, the sodium potassium pump is present, of course, and it has got 5 binding sites everywhere. Of course, it has got 5 binding sites. The 3 binding sites are on the inner aspect of the cell, inside aspect, the sodium binding, ATP binding, and the phosphorylation site. And 2 binding sites are on the extracellular side of the pump. As you can see in the diagram, potassium binding site and obane binding site. And you know the activity of the pump, that it will throw the sodium out and it will bring the potassium from outside, that is plasma potassium is brought into the cell. That is the action of sodium potassium pump everywhere in the body. So now digitalis, well, just one more addition, obane binding site. What is this obane? Obane is said to be naturally produced in the body, at least in mammals. It has been found to be produced by certain tissues, like adrenal gland, for instance, is a source of obane. Now digitalis, when it is given, it binds with the on the obane binding site, which is facing the extracellular side. So there is now competition for between potassium and digitalis for the binding. Actually, what happens is digitalis binds with the pump on the obane binding site and it inhibits the pump. It inhibits the sodium potassium pump. And since sodium potassium pump is inhibited, the secondary active transporters which were dependent on the sodium potassium pump activity, they also will not work. And I'm particularly talking about the NCX, sodium calcium exchanger, in the myocardial cell membrane. So this will also not work, and this NCX not working means calcium will not be sent out of the cell. That means calcium concentration will rise inside the myocardial cell, and you know that strength of contraction of any muscle fiber is proportional to the amount of sarcoplasmic calcium. So this is how digitalis will increase the intracellular calcium and will increase the myocardial contractility. However, that's not the point. Point is that it binds to the pump, it inhibits the activity of the pump. Since it inhibits the activity of the pump and also digitalis interferes with potassium binding on the pump, which means what? Which means potassium cannot bind with the pump normally, and potassium cannot be brought from outside to inside of the cell, which means that potassium concentration in the plasma will rise. Again, I repeat once again, potassium binding, they both actually interfere with each other's binding. Potassium and digitalis, they interfere with each other's binding on the sodium potassium pump. So when digitalis interferes with the potassium binding, that means plasma potassium cannot bind with the pump and it cannot be brought into the cell. That means plasma potassium concentration will increase, hyperkalemia. All right, so that was the answer, and that's how digitalis toxicity, one of the manifestations is the hyperkalemia. All right, to conclude this, let me just add here that hypokalemia will potentiate the digitalis toxicity. Can you understand this? If there is hypokalemia already present due to some other reason, then as we saw, potassium is expected to interfere with digitalis binding on the sodium potassium pump. If there is hypokalemia, less potassium, then there is no interference for digitalis binding. So digitalis action will reach the toxic levels. There will be toxicity of digitalis. Or in other words, in digitalis toxicity, what will you administer? Bingo, potassium. Yes, because potassium is going to interfere with digitalis binding and thereby it is going to reduce the digitalis toxicity. So that was the answer to the MCQ. But remember, digitalis and potassium, they are interfering each other, and therefore digitalis will play with the potassium concentration. That's the answer for this MCQ.